Welcome to Westpak's webinar on Hazardous Materials Packaging Certification Overview. I'm Greg Swinghammer. I'll be your moderator and webinar organizer today. Before we get started, let's take a moment to ensure that everyone is ready and familiar with the webinar control panel. First, you should have the control panel on the right side of your screen. You may minimize this panel by clicking on the orange arrow button in the upper left-hand corner. You may expand the panel by clicking on the same button. Secondly, you have the ability to submit questions using the chat pane located near the bottom of the control panel. We will be answering a few questions during the webinar. However, if we're unable to address your questions during the webinar, one of our presenters will follow up with you afterwards via email. Today's webinar and slide deck should be available on Westpak's website by Monday. With that, let's get started. Today's presenters are Edmund, Tang, and Jorge Campos. Edmund is a lab manager here at Westpak and a lecturer at nearby San Jose State University. Jorge is a test engineer too, and Westpak's in-house expert on hazardous materials certification and working with the DOT. If you'd like to listen to any of our other webinars, please check our website under the Events tab. Edmund, you're our first presenter. Take it away.
Thank you for that introduction, Greg. So right here we have the agenda slide, and we're just going to give you a nice overview of what we're going to talk about today. Probably one of the most asked questions is just, what is a hazardous material? How do I know what I'm shipping, what I'm producing is hazardous and requires special shipments? So we're definitely going to answer that first in this presentation. Then we're going to talk about who regulates hazardous materials, which regulating bodies, and pretty much who could give you fines if you're not applying to the rules. Next, we're going to talk about CFR 49, which is also Code of Federal Regulations, which a lot of this presentation will focus on. Then we're going to classify hazardous materials into the 9 different classes. And then we're going to talk about why and how are you transporting your hazardous materials. Then we're going to talk about the benefits of early planning, because to actually get your package certified in order to ship for hazardous materials, it could take quite a bit of time. One, from printing boxes, getting the testing done, and just getting all your material suppliers in line. We're going to talk about package types. Then we're going to talk about how much are you shipping, but because depending on the amount you're shipping, different rules apply and you have to follow a different set of criteria. Then we're going to talk about the requirements to certify a non-bulk UN package. And the reason why we're using a non-bulk UN package today is just because it's one of the most common means of shipping a hazardous material around the world, or at least in the United States. Then we're going to talk about how do we reduce false failures in testing more specifically. And then lastly, we're going to give you an example of the test inputs of a non-bulk package system for hazardous materials. All right, this question, what is a hazardous material? So just a straight definition of that, it's defined as solids, liquids, or gases that can harm people, other living organisms, property, or the environment. And this is very similar to the definition per CFR Section 49, Section 171.8. And it is also commonly known as hazmat or dangerous goods. So anytime anyone says hazmat, dangerous goods, hazardous materials, it's all the same thing. So now Jorge is going to talk about the regulating bodies of hazardous materials.
Thank you, Edmund. In the United States, the Department of Transportation regulates us. And this includes the 49 CFR parts 105 through 180. In the international layer, the International Civil Aviation Organization, otherwise known as ICAO, regulates us. And for international vessel, the International Maritime Organization, IMO, it's who regulates us. It is also worth mentioning that the International Air Transportation Association republishes the regulations of ICAO annually as the dangerous good regulations. It is not a regulating body, but it is a working document that airlines obey by. In this case, it has additional requirements that specific airlines have established as the standard. And if it meets the IATA regulations, it definitely meets the 49 CFR regulations. So what is the Code of Federal Regulations 49? Well, in the United States, there's a total of 50 titles that obey the Code of Federal Regulations. Title 49 is a 9-volume set with Federal Regulations of Transportation. The second volume contains parts 100 through 185, which explains how to transport hazardous materials. Now, Edmund is going to discuss about the hazardous materials classifications.
Thank you, Jorge. So, all hazardous materials are different and they're divided into different packaging groups. So when we talk about packaging groups, it consists of packaging group 1, 2, and 3. Number 1 means that this hazardous material has the greatest danger, and if it actually comes in contact with a living organism property, they probably have the most you could say negative impact. Packaging group 2 has medium danger, which is less than packaging group 1. And then finally we have packaging group 3, which is the least amount of danger. So with regards to packaging group 1, 2, and 3 also relates to how severe you would actually test these package systems. So packaging group 1, you would actually test them at a more severe level than packaging group 1, than packaging group 2, just because the theory is that packaging group 1 is more dangerous, so therefore it should be able to survive higher drops and have actually a higher safety buffer, to say the least. And packaging groups are also determined by the hazardous materials table and also in CFR 49, ICAO, IATA, and IMDG. And then lastly, there's a couple other materials that aren't actually have any packaging groups. They don't actually have any packaging groups, and that's gases, which is class 2, radioactives, class 7, and infectious substances, which is class 6.2. And for these items here, they actually follow a different set of rules and a different set of testing requirements. So here we just have a nice illustration and a nice table of the 9 packaging classes. But we put that in a table format, and then we could actually see what each class 1 through 9 is all about. So the first thing that you would notice is that the first 2 lines is forbidden materials and forbidden explosives. So some materials, some explosives, they either, one, they can't be transported in a very quote-unquote safe and normal manner, and if that's the case, they're forbidden, and you actually have to follow a whole different set of rules there. So that's when the class number is none. And it's a very, very special case. Class number 1 classifies explosives. Class number 2 is flammable gases. Class number 3 is flammable liquids. Class number 4 is flammable solids. Class number 5 is oxidizers. Class number 6 is poison. Class number 7 is radioactives. Class number 8 is corrosive materials, and then class number 9 is just miscellaneous hazardous materials that don't really fall onto any of these classes. So when you're dealing with these classes, there's something else that you need to know, and that's the hazardous materials compatibility groups. And these compatibility groups, they're assigned to actually segregate these classes when transporting with each other. So to determine that, you actually look at a segregation table, and this segregation table should tell you one of 3 things. 1, no restrictions applicable, which means that this material, you could travel with any other hazardous materials, and it's okay. You put it in the same truck, you put them side by side, and it's okay, and they shouldn't be able to react with each other, even if something happens. Second is that it may be loaded away from incompatible divisions, and what this means is that these 2 substances, these 2 classes, they could be loaded in the same truck, but then they have to be away from each other, one on each side, one on the left side, one on the right side, one on the front, one on the back. And then the last case is that they may not be loaded at all with each other because they actually, if these 2 substances, they react to each other, the results could be disastrous. And then therefore it's governed by, these 2 can't even travel together. It doesn't matter what the case is, they just can't travel together. So I guess I didn't answer this question yet of how do you know if your product is hazardous to ship? So the easiest way to determine if your product is hazardous to ship is to look at 49 CFR Appendix A, Table Sections 172.101. And in this CFR section, it pretty much tells you exactly every single material, every single substance that is known as hazardous. So if you go to Google and you search for 49 CFR hazardous substance appendix A, you'll get a PDF, which is actually in the link below. And it's exactly what I described. It's free, and you could look if your material is hazardous or not. And this takes us to our first question. Greg, are there any questions from the audience?
Thanks, Edmund. Currently, we don't have any questions right now, but please remember you can send in questions during the webinar in the chat pane located near the bottom of the webinar control panel. Back to you, Jorge.
Thank you, Greg. Now we're going to talk about how you're transporting your hazardous materials. There are different modes of transportation, that is ground, truck, rail, air, and that requires some additional requirements by sections 173.27, in which have special testing for liquids and different requirements for packaging groups 3 that meet with the primary or subsidiary risk of divisions 4.1, 4.2, 4.3, 5.1, or class 8, which they have to meet the packaging group 2 performance level requirements. And then there's also vessel shipping as well. If you're shipping domestically, 49 CFR is what the governing body to certify and to regulate through ground, rail, and air transportation. If you are shipping internationally, that is truck, sea, and air, 49 CFR can be of assistance to help you ship from the United States to another country. However, you must also meet the other countries of destination requirements, in which IATA regulations can be of assistance to guide you on that. So, what are the benefits of early planning? Well, most definitely you can save money and time on the product launch. If you have early discussions with your internal hazmat expert, your third-party test laboratory, and your packaging supplier. You definitely want to discuss with your hazmat expert whether or not you're meeting the regulations requirements in order to ship your product with the pertinent authorities. You definitely want to define the package type that you are to use, confirm that you don't need or do need special permits and apply for them before testing starts, and that you also want to know that you meet that specific country of destination requirements to where you're shipping to, and most definitely training your staff accordingly before they can ship any hazardous goods. The second team that you want to talk to is your testing laboratory, and that is to discuss what the test inputs are going to be, the number of samples and supplies for testing that you are going to use. What are the documentation requirements for you to obtain a certifying document, and the type of ballast weights that you can use for your testing? And we'll talk more about this down in the presentation. And most definitely, you want to discuss with your packaging suppliers designs for the most suitable and rigid package system for your product specific. What are the packaging types out there that you can ship your packages? Well, for non-bulk packages, you have things such as combination packages, which is the most common package system, in which includes inner packagings. You'll notice that we interchangeably use the word packages and packagings. Packagings is a specific term utilized by the UN regulations. You also have a single packaging in which, in this case, it's basically an example would be a drum in which it only has liquid inside, and since you only have you don't have inner packagings, it is considered a single package. And you also have composite packages in which you are essentially having one container covering another container. Then you have the bulk packaging group, which includes semi-bulk packages and large packages as well. In addition, there's another item to consider, and that is the exceptions, which is not fully discussed in this webinar. However, we wanted to bring it up as awareness. That is limited quantities, consumer commodities, and accepted quantities. There are some benefits of utilizing this particular shipping methods in which you will not be required to certify a package. That's the number one. Number two, the declaration of your documents is easier, and it's much easier to ship any of these three. There's definitely benefits into shipping without doing any testing for limited quantities and consumer commodities. However, for accepted quantities, you do have to have some testing, and you are required to do a lot of paperwork. It's almost, in my opinion, equivalent to obtaining a full UN certification. However, if your package systems or your quantities being shipped, and if your product qualifies, you may use any of these three modes without having to certify a package system. So, still deciding on how much to ship. Well, non-bulk packaging, the requirements for solids is that you must meet equal to or less than 400 kilograms, and your maximum volumetric capacity must not exceed 450 liters. For liquids, you must not exceed a total of 450 liters in a receptacle capacity. And for gases, you also can exceed a total of 454 kilograms of water capacity of the receptacle itself. For large packages, you must exceed 400 kilograms of net mass or exceed 450 liters of volumetric capacity. However, the volume of the receptacle must not exceed 3,000 liters. And there's other requirements for this particular as well, such as it has to have inner packagings or articles. For anything over 400 kilograms and 450 liters for solids qualifies as bulk packaging. For liquids, as long as you're exceeding 450 liters, it is considered a bulk package. And for gases, anything exceeding 454 kilograms of water capacity. So what are the requirements to certify a non-bulk UN package? Well, there are several things that a testing lab is going to require. And the first one is the hazardous materials information. And this is the basic descriptions, which we're going to talk about them in a second. The packaging materials information, which includes drawings and specifications. The packaging methods and the process of packaging the hazardous material component, as well as the packaging supplies. For hazardous materials information, we need to know the name of the hazardous material product, your commercial name. We also need to know a part number in which that product can be tracked using your system, the UN proper name, and the UN number. If you are shipping solids, we need to be able to quantify what is it that you have and how much of it you have. In this case, descriptions such as grain, size, weight, and dimensions are parameters that can help us document and submit to DOT. When choosing ballast to substitute the hazardous material component when testing, we must find ballast that meets similar characteristics to the actual dangerous goods product. And when testing, the package system with the ballast must weight the total intended rated weight. If we are certifying liquids, we must know the specific gravity and the viscosity. For ballast, it varies for non-plastic inner containers as well as for plastic inner containers. Now we're going to take a break for questions from the audience. Greg, are there any questions from our audience?
Thanks, Jorge. Yeah, we have a question here. How often are changes to the CFR regarding classifications of hazardous materials made?
I'll take that question. So changes to CFR regarding classifications of hazardous materials are continuously happening. It doesn't actually happen within a certain interval. So it's not once every 6 months, it's not once every 3 months. It's whenever the DOT pretty much deems that classification changes are needed. And then, as you notice, DOT, the CFR 49, year to year they have a new publication, but then even before the new publication comes out, pretty much the DOT department can say that, oh, here's an addendum to the document. It's posted on our website, and it's pretty much everyone's responsibility, especially the shippers, to before they ship it, just to go on to the DOT website just to make sure that the classifications of the material still stands. But there's no quote-unquote plan changes. It's whenever they're needed.
Cool. Thanks, Edmund. We have another question here. Can you specify what is ballast? Give a little bit more detail about it.
Thank you, Greg. I'll take that question. So the ballast in this particular case is basically the substitution of the actual hazmat product. So, for example, say that you have you're shipping a chemical inside of a bottle container. The chemical itself would not be tested. Rather, we would be using something else. So ballast is basically the substitution. In this case, might be water if you have a non-plastic container, or antifreezer if you have a plastic container.
Great. Thanks, Jorge. We have one more question here. Who enforces the regulations of IATA, DOT, and IMDG?
I will take that question now, Greg. So in the United States, the governing body would be the Department of Transportation. Internationally, it's dependent on which country the dangerous good is being shipped to. For this particular case, let's see, we have three bodies that you're asking. You're asking for IATA. IATA is not a regulating body, although they publish regulations recommended by certain specific airlines. And a lot of times IATA's regulations specifications are greater than what the US DOT specifies, and because of that, many follow it. However, these are not rules. So in other words, you can have something by DOT that says this is legal to ship. However, if it doesn't meet the IATA regulations, IATA may not, the airline that it's been shipping may not necessarily accept it. IMDG is also regulated in this case if it's leading from the US DOT, and so forth.
Great, thank you, Jorge. If we don't have a chance to get to everybody's questions at the end, we will come back around and contact you. So, but please keep sending in these good questions. Back to you, Edmund.
Thank you, Greg. Now we're going to talk about the process of packaging the dangerous goods component, what kind of documentation you need, and pretty much what makes the regulating bodies happy and what's acceptable or not. So the first thing that you notice is that it's a very detailed packaging instructions. And I actually have an example of this on the next page. But then with this very detailed packaging instructions, you're specifying things like, oh, what model number of a tape gun you're using. And like in this picture here, it's using an automatic box sealer. So it's going to be, oh, we're using the Bell 130 box sealer with a tension setting of 8 and yada, 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 other settings like that. So every setting needs to be specified. One for traceability, but pretty much is for traceability. And if anything goes wrong, they want to see where in the process something went wrong. Other documents that you need, again, is just the make, model, and equipment settings, and that's what I just said. So here's an example of just taping the box and the instructions you need. So this slide is like this on purpose, and it's just a whole bunch of text, but I'm going to read it for everybody really, really fast right now. But here we go. First, the die-cut RSC, regular slotted container, will be erected by hand. The bottom of the shipper is then sealed by hand on the closing faces with 4 strips of 3-inch 3M nominal translucent pressure-sensitive fiberglass reinforced tape. The first strip is taped applied parallel to the lengthwise closing flap with a minimum length of 20.62 inches, factoring the minimum overhang of 76.2 per side. The second and third additional strips of tape is applied parallel to the widthwise closing flaps with a minimum length of 12.02 inches, factoring the minimum overhang of 3 inches per side. The fourth piece of tape is applied perpendicular to the center of the length of the closing flap with a minimum length of 6 inches, equally divided between 2 sides. The tape is cut with a Y scissor model number 428N, part number 186-428N. So all that is needed just to tape the box. So you could see how detailed the certifying bodies want you to be, because again, we're dealing with hazardous materials here. And if anything goes wrong, they want to see where we went wrong, where in the process we went wrong, and pretty much if anything wasn't followed to every single detail that we just described. Other details that you need is just minimum requirements of component name, manufacturer's name and address, part number, material makeup. And again, all this goes back to documentation and traceability. And this is very important, especially for material makeup, because, for instance, you cushion your bottle with 1/2 inch of this cushioning material, and something happens in the field, and then they measure this cushioning material, and instead of 1/2 inch, they measure at 1/4 inch. And then now there's a discrepancy because obviously the thickness is different than what was specified. And did this cause the failure? And if it caused the failure, then obviously there's going to be some fines associated with it, and you have a chemical spill that you need to clean up, but then it's just a mess. So documentation is required for traceability. Additional requirements is drawings. Everything that has that can be drawn, you probably need a drawing. Right here we have just a drawing of the RSC box, and then on the right side we just have a drawing of a bottle that specifies the height, width, gauge, thickness, the torque settings, and the thread settings as well. And then you also need weight, and you also need the quantity of each packaging materials, each packaging component. So when you're rating a box, you're talking, one of the key terms that you're going to hear is maximum permissible gross mass. So with this term here, it's also known as a weight rating. And the definition of this is just the weight of the packaging plus the weight of its shipping contents, stated in kilograms. And what this is the whole package as one and how you would ship it normally. So if you know that your box is going to weigh around 16 pounds, or we're dealing with kilograms here, so you're just saying that it's going to weigh 16 kilograms here. You want a weight rating of a little higher than that, maybe 17, maybe 16.5. And the reason why is because you just want to have a little extra leeway in case you have additional packaging materials, because a lot of packaging materials is specified in a minimum, for instance, minimum tape length, and therefore sometimes people actually add a little more tape, and then you just want to make sure those variances don't push your packaging weight above the weight rating. And if it does get pushed above, you're definitely going to get fined as well. So that's just one thing to be cautious about. Now we're going to talk about recommended quantities of packagings and samples, and this is actually in specifically to testing per CFR 49, sections 178. So when you're testing a package per CFR 49, section 178, you definitely need 5 fully configured package systems filled with ballast weights to replace the dangerous goods component. And these 5 package systems, they'll be subjected to various different tests. But then I definitely want to talk about I wanted to highlight the ballast weight, because ballast weight, Jorge actually has a few slides on that, but it's very, very important, because ballast weights actually, if you do it incorrectly, it's going to cause false failures. But like I said, Jorge is going to talk about that. I just wanted to highlight it and bring attention to it. And we also need one complete package system without ballast for the material testing. So this package system, it's going to be untested, it's going to be virgin material, and then when we take the properties of it, we want to just make sure that we're testing something that hasn't deteriorated from all the testing that we're doing on the other side. And then you just need closure supplies such as nails, tapes, etc. And again, these tapes, you have to specify a length. For the nails, you have to specify the number of nails, and you also have to specify the distance between each nails. So yes, again, details, details, details. And now Jorge is going to talk about how do you prepare your samples.
Thank you, Edmund. If we are preparing ballast weight and sample packages for testing, we definitely want to substitute the hazardous materials component with ballast weight. And the ballast weight should be very similar to the dangerous good component being tested. In this case, it'll be in texture, geometry, density, and weight. Some of the benefits of doing this is that you would be able to see the performance of your product with respect to testing. For example, if you use a square shape metal piece, you may not necessarily see what your product is doing or how it's performing when being tested. It definitely gives a false results because one, you don't know if you have enough cushion to protect it, and two, you don't know if you're spending too much money on preparing something that doesn't require that much cushioning. When preparing for liquids, we are substituting for either with water or with antifreezer. The difference comes when you have inner containers that are non-plastic. Anything that is non-plastic will be conditioned to 23 degrees Celsius, 50% relative humidity for a minimum of 24 hours. And Edmund will be discussing more in depth when we get to the testing section. And the containers must be filled with water to a 98% volumetric capacity and not the nominal capacity of a container. For example, if a bottle has a nominal capacity of 1 liter, chances are you can add more to it, say either a couple hundred milliliters, and you must make sure that you use that. Now, it is understandable that you are not going to fill your container to 98% of capacity when shipping. However, it has to be tested this way for performance testing. Whenever testing with plastic inner containers, antifreeze is ideal or similar. And the reasoning behind this is the package system is going to experience minus 18 degrees Celsius for a minimum of 24 hours. What this is going to do, it's going to, if applicable, it's going to make the containers more brittle. And it'll also requires that if it breaks at any point in time, that it's easy to see if liquid is coming out of the container. Also, when testing with water, what happens is that the bottle expands, and hence you'll have false failures as well. And you must also fill it to 98% of volumetric capacity and not nominal capacity. So how do I minimize false failures? Well, most definitely it requires some planning ahead in terms of the type of ballast weight that you're going to use for your testing. It is recommended, most definitely it is recommended that you fill the containers and utilize your own closing systems to help detect any faults or any process issues that you may or may not be having. A lot of times issues arise when we're testing a paste-like material and simply replace it with items like water, for example. This is something that is common because you may exhibit leakage when doing the pressure testing. However, if you are able to find a similar paste-like material that replaces the hazmat component that has similar texture, geometry, and density, that might actually give you better results, and it'll provide you with the kind of information that you want to ultimately see if your package system is suitable for transportation. Now, we're going to take a quick break for questions. Greg, are there any questions from the audience?
Thanks, Jorge. Yeah, we have a few questions here. The first one is, why is a die-cut RSC required, or is a standard corrugated manufactured considered a die-cut?
So a quote-unquote a die-cut RSC is not required. We just said die-cut RSC, for example, just because at Westpak almost every single corrugated fiberboard box comes in is a die-cut RSC. So from our standpoint, it's definitely one of the most common corrugated fiberboard construction types. But then if you were to actually look at the pretty much the guidelines of a corrugated fiberboard box, it would be in CFR 49 sections 178.516. Again, for standards for a fiberboard box, it's sections 178.516.
Cool. Thanks, Edmund. Next question is related to ballast density. Is there a latitude with specific gravity?
I'll take that one, Greg. Basically, and we'll talk about that during the drop testing, but basically the way it's related is with so as the specific gravity exceeds 1.2, and that's the cutoff line, it's compensated with a higher drop height, and this comes down to liquids, of course, and we would see this later on better explained on the following slides.
Cool, great, thanks guys. Let's get back to the show. Remember, everybody, send in your questions and we'll try and get to them. Back to you, Edmund.
Thank you, Greg. So this takes us to the final part of this webinar today, which is just a sample of testing and what would happen if you bought a non-bulk packaged pretty much for certification. So remember, Jorge predefined this at first, but then we'll say it again. A non-bulk packaging is less than 450 liters, which is 119 gallons in volumetric capacity, and less than 400 kilograms, which is 882 pounds. So the first thing that you would do for your package systems is that you would do conditioning. So with conditioning, you need 5 different packages. And the reason why you do conditioning is because you want to acclimate the packages to quote-unquote normal ambient temperatures and humidities prior to drop testing. Because, sometimes your box will come from a place that's really, really humid, or on the flip side, your box might come from a place that's really, really dry. So we just want to make sure that pretty much when you're testing these boxes, whether it comes from Florida or whether it comes from California, that you're all testing to the same conditions and all boxes are created equal, to say the least. And then so with that, you test it, you condition them at 2350 for a minimum of 24 hours. However, if you do test for the liquids that Jorge was talking about first, in a plastic container, you condition them to minus 18 degrees C. And the reason why you condition these packages, these bottles, to minus 18 degrees C is because we want to test what happens when these bottles get brittle, when these closures get brittle and you drop them. Will these closures just pop off? Will these bottles actually just crack? And the only way that you know is that you subject them to freezing temperatures for 24 hours and then you drop them right afterwards. But just remember that when we're actually conditioning them, that the water inside is not water, it's glycol water or antifreeze, just to prevent them from freezing. Because if we have water in there, obviously it'll expand and cause a failure even before you start testing. But same thing, minimum duration is 24 hours, and then we'll do drop testing on them afterwards as well. Now Jorge is going to talk about the actual drop testing of these packages.
Thank you, Edmund. So when conducting drop testing, which is followed after conditioning, the drop sequence or orientations are dependent on the geometry of the outer package. For example, if you have anything that simulates a barrel type, there are a total of 6 drops, and there are a total of 3 drops per drum. In this case, these are some examples of what has to undergo the 6 drops, and there are wooden barrels, steel jerry cans, and drums. And as you can see, of pretty much any of the below materials are applicable. For boxes, which is in this case what we're using as an example, there's a total of 5 drops, and there is 1 drop per box. And boxes, it's of all types as listed here. Some examples are natural wood, plywood, reconstituted wood, fiberboard, plastic, steel, aluminum, or any other material, or composite packaging in the shape of a box. For bags, there are still 3 drops. For bags of single ply, there are 3 drops per bag, and for bags with either without a seam or multiply, are a total of 2 drops per bag. The following list is the drop test orientations for boxes. As previously mentioned, boxes are only required to be dropped once, and we have a total of 5 boxes. And there's no particular order. However, this is how it's listed on the 49 CFR regulations. Drops, 1 box will be dropped on the bottom, another box will be dropped on top, another box will be dropped on the long side, another box on a short side, and the last box will be dropped at a bottom corner, and it's normally the most fragile corner, which in this case, for a corrugated box, it'll be the manufacturer's joint. When dropping solids, we have different heights based on the packaging group type. For packaging group 1, the drop height is established as 1.8 meters, which is equivalent to 5.9 feet. Packaging group 2 to 1.2 meters or 3.9 feet, and packaging group 3 to 0.8 meters, which is 2.6 feet. When testing liquids, in anything with a specific gravity, and this is why specific gravity is important, when specific gravity is below 1.2, it is tested just the same as the solids. So packaging group 1 remains as 1.8 meters, packaging group 2 as 1.2 meters, and packaging group 3 as 0.8 meters. When the materials with specific gravity exceeds 1.2, the drop height changes, and it is based on 2 things: on the packaging group and also on the specific gravity. For example, if we have a packaging group 2 hazardous material with a specific gravity of 1.4, you would multiply 1.4 times 1, as you can see on the middle column, and hence you will have a drop height of 1.4 meters. Now Edmund is going to talk about the rest of the test inputs.
All right, thank you, Jorge. So this test input that we're talking about is a stacking test. Stacking test, also known as compression test, same deal. So with the stacking test, we need 3 packages, and what you're doing is that you're putting a theoretical test weight on there for a minimum of 24 hours. The formula, universal formula that you use for the stacking test is defined as top load equals minimum stack height divided by height of container minus 1. And the minus 1 is there because you can't stack fractional packages, no such thing, multiplied by the weight of the shipper with its contents, or also known as the rated weight. And this assumes that when you store your packages or when you're stacking them, you're going to have identical packages, therefore you have identical weights on top of them. Here's a formula notes. The simulated stack height predefined is known as 3 meters or 10 feet. The height is the outer height of your corrugated or just your package system, doesn't have to be corrugated. And then the weight is the gross mass or the weighted rate of your package system. And using the same formula, we're actually just going to go through an example here. So the example is that we have a package weight of 5 kilograms, and then you have a package height with outer dimensions of 10 inches. And then 10 feet equals 120 inches. And using the formula on top, what would be the theoretical weight that you would need to hold for 24 hours? So I'm just going to let everybody do this mentally for 20 seconds before I go through the solution. Okay, so now that everyone's had time to calculate this in their heads or take out their pencil and paper and calculators, we could do this calculation. So you take 120 inches and you divide it by 10 inches and you subtract it by 1, and that gives you 11, and then you multiply it by the rated weight of your package system, which is 5 kilograms, and then you get a test input, a test value of 55 kilograms for a minimum of 24 hours. And that is how you would complete this compression test. Next, you would test to vibration. With this vibration, you also have a quantity of 3 packages, and then you would just vibrate your packages for a total of 1 hour. So what frequency or how fast do you vibrate your packages? And that's defined as below. So you just want your vibration table, whether it be rotary or linear, to be fast enough that causes the package to be raised from the vibration platform to allow 1.6 millimeters or 0.63 inches thickness, such as a steel strapping or paperboard, to be passed between the bottom of the packages and the platform. So you just want to be able to shim something through it without much resistance. Then you go through a pressure differential test, and of course this is only for liquids. And then with this pressure differential test, what you're doing is that you're implying an internal pressure of either 95 kPa for packaging groups 1 and 2 or 75 kPa for packaging groups 3 for a duration of 30 minutes. And then so with this test, you're just making sure that the closure doesn't leak when you apply the internal pressure. And I say closure because that's the most common failure mode of testing a package like this. Sure, if you're testing like a really, really weak package, the whole thing could blow up. We haven't seen that before, so that's why we say closure. And if it does blow up, you know that you have some serious problems here. And again, this, I didn't mention this, but then it's on the slide. This is only for air transportation if you're doing this test. So now, at the end of the day, how do you know if your package system passed or failed? So you know your package system passes if it meets the following criteria. 1, there's no rupture or leakage from any of the packages. 2, no test samples should show any deterioration which could adversely affect transportation safety or any distortionable liable to reduced packaging strength. Let me give you an example of that. So you do a drop test on a corner and the corner gets dinged. And then you open your package up, and then everything else inside seems fine. The corner did its job. It gets dinged, yes, that's fine. But then everything else is pretty much unscathed. That would still be a pass. But then let me give you another example. For instance, if you do a vibration test, and after the 1 hour vibration, in addition to the scuffing, the vibration tester result was actually that your tape was actually scuffed off, and the 2 flaps were barely hanging onto each other. And that would be a failure because that is obviously a liability and deteriorated the package that affects the shippability of it. You can't ship that package anymore. Third point is that if you're testing liquids, each individual package should be turned sideways to ensure no leakage is present after every test input. So you just want to make sure after vibration there's no leaking, after drop testing there's no leaking. Of course, during the internal pressure testing, again, there's no leaking. So this is all for the package system testing, to say the least. The last test that we talk about is a materials test, and that is Cobb testing per 49 CFR 178.516, and it also references ISO 535. Quantity, again, is 3 samples, and this is only for fiberboard boxes. And what this test tells you is your fiberboard box's ability to withstand moisture. And this test outline is that you simply apply 100 milliliters of water to a test area of 100 centimeters squared. And this will provide 10 millimeters of water of head to the 100 centimeter square area. You wait 30 minutes and you roll the samples using specified roller and blotting paper. And here's a photograph of this test setup right here. So 3 samples, and it just has water, and it's being tested. So the passing criteria here is that your samples do not absorb more than 155 grams per square meter. And then if it absorbs more, what it tells you is that, one, your corrugated board is likely to absorb a lot of moisture during transportation, just because that's the nature of it. And then what you know about corrugated board is that when it absorbs moisture, it becomes weaker, and weaker in almost all aspects. For compression testing, the strength gets severely lowered, and same thing for drop testing, because your corrugated, you could say, just becomes very soft and mushy. So that's a passing criteria for Cobb testing. So that's actually the end of this presentation. I know Jorge and we talked about a lot today. DOT testing or UNPOP certification testing, it's a data dump. It's a lot of topics. But then if you were to take away anything today, Jorge and I would like you to take away these 5 points. 1, the ability to determine if you're dealing with the hazardous materials. We showed you how to do that. 2, steps to get your package UNPOP certified. 3, knowing the benefits of early planning, because it can be a long process. 4, the importance of using ballast weights during testing to reduce false failures, because that happens very, very often. And then 5, just the testing requirements per CFR 49. And that ends our presentation. Greg, are there any questions from the audience today?
We do have another question here for you guys. Stack test, what defines pass-fail criteria after 24 hours? Is it the packages must remain upright and intact?
I'll take that question. So in addition to the other requirements that we stated, which are, 1, there has to be no deterioration of the package to actually affect shippability of your package. And in addition to that, there's no leakage if you're dealing with any liquids or even solids, just no liquids in that. Once again, if you look at CFR 49 sections 178.606, it'll give you the actual nitty-gritties of all the criteria, but then I did want to highlight the last part of that, which states a container passes the test if after application of the required load, there's no buckling of the sidewall sufficient to cause damage to its expected contents. In no case may the maximum deflection exceed 1 inch. So that's the criteria.
Thanks, Edmund. That was very interesting. It looks like we got so we got a question here. Could you send a copy of the slide deck out? The slide deck will be on our website, available on Monday, and you can download it from there. So we're kind of running short on time here, and the questions we have left are a little bit lengthy to fit into the time constraints we have. So we're going to kind of wrap things up here. So thank you, Edmund and Jorge, for that fine presentation. As I said, please check our website under the Resources Webinar tab for upcoming topics. You can register there for the next webinar or wait for your personal invitation in your inbox. We have 2 locations, one in San Jose, California, and one in San Diego, California. Please don't hesitate to contact us. If you missed anything or would like to listen to the webinar again, please go to Westpak's website at www.westpak.com under the Events and Resources tab. The webinar material should be uploaded by Monday, like I said. We will be sending out a short survey with an within an hour, please fill it out as we highly value your opinion regarding today's webinar. You will also have the opportunity to ask questions or suggest a new webinar topic. Thank you for attending today's webinar. I'm Greg Swinghammer. Make it a great day.